Hey class, I don't know about you, but I am excited there are only a few more days till Thanksgiving break. As you watch this video, make sure you're using your Frayer model in your notes, and please pardon my voice, I'm a little hoarse today. You're looking at the page, it looks like this. It has scatter plot in the middle. We're going to look at some definitions and characteristics, and then we're going to do some examples and non-examples. Looking at the top left corner, we're going to look at the definition. A scatter plot is a type of graph that is used to study relationships or correlations between two variables. So the first thing we want to know is that this is used to study correlations. And a correlation is just a relationship. The next thing, each point in a bivariate set of data is plotted, then conclusions can be drawn from the way the points are distributed on the graph. So we use a scatter plot to draw conclusions from the data. We can tell that on our scatter plot which direction it is moving. For instance, we talked about yesterday our positive, negative, and no correlations. And we draw conclusions from the data, and we can make predictions with these scatter plots, and we can see what's going to happen in the future. In class and on the video last week, we talked about our correlations. Our characteristics include positive, negative, or no correlation. Remember that a positive correlation is increasing from left to right, a negative correlation is decreasing from left to right, and no correlation, there is no pattern in the graph that shows us if it's increasing or decreasing. Some other characteristics we can just use to describe a scatter plot is if it is linear or nonlinear. We're going to work on linear and nonlinear graphs on Wednesday in class. Linear just means that our pattern goes in a line. Nonlinear means that it does not go in a line. So linear has the word line. Nonlinear means it's not in a line. And the last thing we look at for our characteristics is if there's a strong or a weak correlation. A strong correlation means that the the points show a pattern that increases or decreases, and they are kind of in a good line for us. A weak correlation means they're a little more scattered out. They can still show the same pattern, but they're more scattered throughout the graph. Looking at the bottom left corner, we're going to look at an example of a scatter plot. This graph, I know it's small, but the top says car ownership in any town by household income. And our scatter plot shows us our income in dollars and the percent of the population that owns a car. So as the household income increases, it's more likely that more people will own a car for that family. Now, you can use a trend line to make a prediction. A trend line is a line that goes through the data. It is not a dot to dot. We're going to draw a trend line together on this graph. We can tell that this is increasing. It's got a positive correlation. And if we draw a line, we want to go through as much of the data as possible, but it is not a dot to dot. It's a straight line through our data that shows the trend. Now, you'll notice that I don't go dot to dot and connect them, but it goes increasing from left to right, and it follows the same pattern. You wouldn't want a very steep line here or a very flat line here. You want it to go through the data, and you want about the same number above your line as below your line. We're going to work on drawing trend lines in class on Tuesday. Now, you can use your trend line to make predictions. For example, if I wanted to see the approximate amount of people who own a car, if their household income is $70,000, you can use your trend line and go up at 70,000. Let's see if I can draw a straight line. And when I get to my trend line, I can predict that about 87% of households that have an income of $70,000 own a car. So your trend lines are useful for you in making predictions. We're going to work on making predictions in class tomorrow on Tuesday. Now, this is a non-example in the bottom right corner. of our, it's not example, this is not a scatter plot. This figure shows us the labor force participation in Andrews High School. And we have each month, and then on this side, we have the number of students involved. Now, this is not a scatter plot. This is a line plot or a line graph. Remember, you learned in probably 4th or 5th grade about line graphs, and they're just points where the line connects them. You'll see line graphs a lot in things like the stock market. They show how the data changes from one time to the next. On line graphs, the bottom is usually, the x-axis is usually time. This is a line graph. In scatter plots, we don't connect the points dot to dot like this one is. Then, if we do that, it makes it a line graph. So for our conclusions, we wanted to remember about our trend lines and making predictions. Trend lines show the trend in the data. If you'll just write this on your page, I know there's not a spot on your Frayer model. It shows the trend in the data. It is not used to connect the dots. Trend lines will be a straight line through the data with the same amount above and below the line. It does not connect dot to dot. We use our trend lines to make predictions, and we can look at the x or y axis. And when we look at the x or y axis, we use our trend line to help us predict for a given number. So we use our trend line to make predictions. All right, we're going to work on our scatter plots in class on Tuesday using our trend lines to make predictions. On Wednesday, we're going to look at linear and nonlinear graphs. And don't forget, this Thursday, you have your CFA. Only a few more days to go before Thanksgiving break.